massive asteroid from outer space heads straight for Earth. It's as large as the one that impacted over 4 billion years ago. This computer simulation has been made with the scientific advice of geophysical experts to show the effects if the impact were to happen today. The asteroid's diameter is larger than the main island of Japan. Even though it is moving at over 720,000 kilometers an hour, that's almost 450,000 miles an hour, the asteroid appears eerily slow because of its size. The actual impact happens in the Pacific Ocean, just under 1,000 miles south of Japan. The crust of the Earth is peeled away like an orange skin by what is called the crest tsunami. Even the deepest part of the Pacific Ocean looks like a thin film. Huge chunks of debris the size of city blocks are hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. At 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start. NASA has the world's largest collision test machine used to try and find out what would happen after the moment of impact.
Okay.
Dr. Peter Schultz fills a small tank with water to see how the ocean would react. The actual impact object is tiny, but it will hit the water at a speed 20 times faster than a bullet fired from a pistol.
Oh, gorgeous. Joe, that is gorgeous.
Just one tiny aluminum bullet had this result. But the impact which created mayhem is not the entire story. To get the full picture, the moment of impact has been slowed down so that 1 second seems to last an eternity. At the moment of impact, it is like slamming the brakes on. The kinetic energy of the bullet is transformed into heat. White smoke rises. It may look like a splash, but it is actually water vapor. The heat vaporizes the water in an instant. And heat has a deadly potential.
When an asteroid hits the surface of the Earth, the material is heated up to temperatures that get up to the point of, say, 4,000 to 6,000 degrees centigrade. This is as hot as the surface of the sun.
An experiment was carried out at Hokkaido University in northern Japan to try and discover what could happen to the rock bed at the point of impact. A tiny rock was put into a special oven that could cook the sample to a temperature of over 2000 Celsius, 3600 Fahrenheit. As the temperature rose higher, the rock began to melt and boil like water. The gas produced is called rock vapor.
The rock vapor, when we generate this rock vapor, it will expand extremely fast. It expands so quickly that it can cover eventually the entire planet. When an impact hits, it's not just the crater that forms, it's not just the area where the impact occurred. It's all the heating that's created in the atmosphere and around it. So heat really is the killer.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact?